है ना, तो वो अच्छी रहेगी।
So, reflection is what light, when light travels in the same medium, when it hits the any shiny surface, then incident ray, and then it's reflect back. So from the normal, whatever angle incident ray is making, that is angle of incidence. So here angle I is always equal to angle R, and incident ray, normal and reflected ray all lie on same plane.
Okay.
Correct?
Yes.
Right? But what in case of refraction? Here, when light travels in two different mediums. See, when light travel in the same medium, beta, the velocity of light, it will be what? Same?
Yes.
Correct? But what happens? Just like right now is sunny day, you are running on the road, your velocity will be remain same. But what happens if you are running on a sunny day, now suddenly wind starts coming. So your speed will be little bit less, especially in the riding of bicycle.
Yes.
Correct? So similarly here also, when light travels in two different mediums, obviously velocity changes. Correct? Correct?
Yes.
Now, there are two terms, rarer, denser. Now, what does it mean? Rarer mediums means where intermolecular bonding is less as compared to denser. Example, if I will say air and I will say denser medium as glass, so, or water, okay, the intermolecular bonding of air is loose as compared to glass and water. Correct or not? Understood?
Yes.
So this is known as air is also a what? Medium. Glass and water is also a what? Medium. Understood this part? Now see here, these two diagrams. This is known as what? Refraction. Why? Because light is moving from air, right, to glass slab and then again air. Okay. So air is known as what? Denser medium or the rarer medium?
Razors.
Very good. And glass slab is?
Denser.
Very good. Understood? So
Yes.
tell me one thing. In rarer medium, your speed will be more or less? When it is not windy, that time your speed is more or less?
More.
So rarer is what as compared to denser? Its intermolecular bonding is less. So the speed of light will be what? Less or more?
More.
Be confident now, you are saying right. So the speed of light in rarer medium is more. Is this clear?
Yes.
Whereas speed of light in denser medium is less. Why? Because of strong intermolecular bonding right, of molecules. Clear है बेटा?
हाँ.
Okay. Now, so if my incident ray is coming with some velocity, okay, when it goes to the denser medium, obviously we have studied that the speed of light will be what? Less.
Less.
So it will move towards the normal. If suppose this is 30 degree, this might be 20, maybe 25, whatever. What is the main criteria? When a ray of light moves from rarer medium to medium, then its velocity or speed decreases, due to which it moves, towards normal. Is this clear?
Yes.
Any doubt?
No.
Very good. Now, what about the second? When the light travels from denser to rarer medium, here the speed of light is what? Low. When it goes to rarer medium, the speed of light will be more. So because of that reason, suppose if your mom is sitting behind you, you have to study. Previously, mom left, your masti time is more. Mom entered, masti time is less. Again, mom go, lot of masti comes out. Correct hai, Anushka? Right?
Yes.
Similarly, here also, light travels from rarer to denser, velocity decreases. Denser to rarer, obviously velocity will be more. And more velocity because it was denser to rarer it is coming. So because of more velocity, light will move with greater speed. It means it will move away from the normal. Suppose this is your 20. Tanishka, see here. Suppose this is your 20. Tanishka, see here.
Yes.
Then this angle is equal to this angle,
Yes.
right? Parallel rays of light, then this angle is equals to this angle. This angle is also 20. Then this may be 35
Yes.
because it is moving away from the normal. So write it down in your notebook that when a ray of light moves from denser to rarer medium, then its speed increases, due to which it moves away from the normal. Is this clear?
Yes, ma'am.
Any doubt?
No.
Very good. Now, you You can see here in the image also that when a ray of light, suppose this is your incident ray. Wait a minute, I'm changing the color. Suppose this is my incident ray. So when it enters, it is what? This is your normal. It moves towards the normal. This angle is so high, this angle is so low. This is also what? Normal. This angle is equals to this angle, you can observe it. And now this is what? Too much higher, greater angle. This is clear. Now, when you read extended, okay, distance between, this is your what? Your incident ray. I have incremented incident ray. The distance between incident ray and the reflected ray is known as what? Lateral dispersion. Understood? Listen one thing. This is known as incident ray. This is when it goes inside the medium. It is known as what? Refracted ray. Okay. When it comes out from denser to rarer medium, it is known as what? Emergent ray. Clear?
Yes.
We can observe the tone is for better clarity of the laser beam. For the activity, we are taking a powerful green laser torch. Now switch it on.
This is when it doesn't hit the glass slab. Okay. The ray of light is going straight.
We can observe
Now, when it hits the glass slab, the ray of light has been bent.
Yeah.
the laser beam travel in a straight line in air medium.
Now here you can see beta, when it hits the light, when it hits the surface, this is your normal. This is your angle I. The same angle is your R also. Here you can see the reflected ray is also there. Understood? Similarly, here also, this is not so clear. Wait a minute, it will be. There also the refraction takes place.
But when it is passing through the glass slab, it bends.
Clear?
This bending of laser beam or visible light when it travels from one this bending of
See here. You can see when it going, when we are talking about this. This is your angle I, this is your angle R. Reflection.
Yeah.
Right? So everywhere, whether it is a glass lamp, whether it is a water, you might have seen that at the edge of the water is so shiny, sparkling type. Have you observed maybe in the swimming pool, maybe in the edge of the, you can say, ocean, right? The sparkling lights are coming out. It's just because of the reflection of light. Is this clear?
Yes.
of laser beam or visible light when it travels from one transparent medium to the other is known as refraction of light.
Here,
Here, the
now, one important thing, write it down in the notes also. When incident ray is equal to, an angle of incidence is equal to 0. It means it is just as a normal. Correct? Because from the normal, we are taking the incident angle. Correct, beta? Right? So when incident angle is equals to 0, then light goes straight without any deviation. Is this clear?
Yeah.
You can see here practically also. Correct? Without any deviation, the light will go straight. But as angle increases, as incident angle increases, the deviation starts forming. Clear?
Yes.
Laser beam is falling normally on the glass slab. That means angle of incidence is 0 degree. So here light travel straight in glass slab without any bending or refraction. Now change the direction of
Tanishka, see here with you.
laser beam and increase the angle of incidence. You will observe a slight bending of laser beam towards the normal in the glass slab. Increase the angle of incidence further and you can see the amount of bending of laser beam also increases. Observe the
Now,
amount of bending of laser beam also increases.
you can see here. Now it will be perpendicular, so I will have paused here. This is your angle of incidence. This is your angle of reflection. Reflection, not refraction. This is the angle of refraction. This is the angle of incidence for this glass slab. And this is your emergent ray, angle of emergence. Right? Now, you might observe that now this light will go here. Perpendicular. Right now it's become how much? 985 something. When it becomes perpendicular, see here.
Observe the
Now you can see here. It becomes what? Perpendicular now.
Yes.
This is your angle of incidence. This is your angle of reflection. Some here, this one is angle of refraction. This here, somewhere, this is your angle of emergent. This is your angle of refraction. This is your angle of emergent. Now this angle of emergent is what? 90 degree to my normal. Correct?
Yeah.
Write it down. When angle of emergent is equals to 90 degree to the normal, then that angle of incident is known as critical angle. Understood, Tanishka?
Yes.
Write it down.
Yes, ma'am.
Written, maybe? Understood what is critical angle?
Yes.
This angle of incidence is known as critical angle when the emergent angle is become 90 degree to my normal. Okay, most other kids have a confusion that critical angle is this one. No, this is not the critical angle. The angle of incidence is known as the critical angle.
Okay.
refraction of laser beam through a different angle for better clarity. Here you can see in air medium the laser goes straight, but when it enters the glass medium, bending takes place.
Here you can see very clearly that this angle is what? Reflection angle. This angle is what? Reflection angle. Correct? You can see the light
Yeah.
images. The reflection always takes place whenever the incident ray takes place. Don't forget that.
Let's now understand the phenomenon.
Understood this part? Any doubt here?
Clear, ma'am.
Ka?
हाँ.
श्योर है तो बढ़िया. क्या?
Clear.
तो इसके बारे में ही हमने ये सारी चीजें पढ़ी. Now I am giving you the notes. Just go through it. Okay.